I think we can start our webinar. Uh, this is the first webinar in this year organized by Avicon. So our goal for these webinars is to show technicalities of doing machine vision systems and to present technology in the first row. So this very first webinar is devoted to software part, because the software part is the heart of the image processing. So topic of today's webinar is, let me just show you, okay, is building Zebra Aurora Studio application without writing code. So the topic is the software called Zebra Aurora. This is the environment for rapid development of machine vision applications. So this software uh, provides all stages of application, starting from image acquisition through image preprocessing and algorithm development, and as an output of results, we can output them to both HMI, which is the user interface, and then we can output it to external environments, external systems, third-party systems like PLCs, production lines, information systems, etc., etc. Before we start with agenda, I have 4 points to cover formally. So today's first point is that today's meeting will be held in English language because as you might know or not, Avicon has a broader range of business outside the Poland, and today we are also welcoming the guests from abroad. So English is the default one. For the second, today's presentation will show specific trademarks of third parties. Formally, we are not bound, we are not paid to show these trademarks. These trademarks are totally random, so to say. So we have no connection whatsoever. So please treat it lightly, if possible. Third one is that if you experience any technical difficulties during the broadcast, please mark it in the chat. And the next one, after my presentation, there will be a Q&A section, and you are also free to use your chat just along the presentation to put in your questions. These questions will be answered afterwards. And last but not least, today's presentation is recorded, so it will be available for everyone who didn't make it to this presentation online, so that we make sure that everyone that's subscribed for this event can watch it at later time. Also you. Okay, so going to quickly to cover agenda. So in the first row, I will introduce you to the scenario of today's application. The application is very simple. The goal is not to go too much into development, but to show you the ins and outs, nuts and bolts of the software itself. And then I will cover quickly our setup we have today, because setup this is the live presentation. We have nothing prepared in advance, so this is kind of showdown of live coding for or live development for the sake of presentation. And then I will just cover quickly Zebra Aurora interface. In the next steps, we will run the setup from cold and dark state to ready to go image acquisition, and we will show how to quickly preprocess some things in the image if in case the preprocessing options are needed. And the point three is the so-called big three of the image processing, which is fixture and presence tools, barcode reading, and OCR. So we will try to match all of these tools in single workflow application. And the last thing, we will we will show results in HMI control, because Zebra Aurora has capabilities to develop the screen, which is called human machine interface. So this functionality exposes the program to, for instance, to operator on the production line. And that's it. Okay, let's go for the live view and let's jump into development right away. Let me, yes, share and share entire screen. Okay, now you should see my screen. You should see my screen. And the window is the Zebra Aurora Studio. So before we go into Zebra Aurora, I will ask my colleague Philip just to show you quickly our setup. If you could show us the setup. If you yes, so right now we have a setup. It is the view of the camera is taken from the front of system. So we have here we have the camera, which is pointing to the object in specific position. The objects are the sauce bottles, condiments, and then there is an introduced kind of lighting. In this case, this is the bar line. It will be needed for us just in order to make better illumination. The camera is connected to my laptop via USB 3.0 interface. This interface provides a quite high throughput of the images to the computer, and the bandwidth can reach as much as 350 megabytes per second, which converts to quite high frame rates possible for the camera. I use Basler camera for today's presentation, and TPL lighting for illumination of the scene. And I have several cases for back label inspection. Yeah, back label inspection. You will see them in algorithm view, and we will try to make a simple application that checks for something. Okay, Philip, if you could just switch me to the screen sharing. Right now we are back. Okay, so let's start with the Zebra Aurora Vision Studio window. So it splits into in the basic layout, splits into several areas. So first of all, on the left there is a toolbox area. Toolbox contains all the possible tools and algorithms that we are able to use. These are computer vision algorithms, as well as connectivity algorithms like GigiVision or GeniCam interfaces to acquire the images, as well as third-party devices like, for instance, I/O cards, frame grabbers, and a lot of different hardware of different vendors that enables us to communicate with the outside world with our results and react to process, for instance. On the middle, we have the program editor. This program editor is the visual drag and drop editor, which has a top-down layout of algorithms. So I will create the top-down flow of my tools in this case. And on the right, I can have the preview of any inputs and outputs of building blocks of my algorithm in the middle. So I can split them into many layouts and have a multiple previews of any data I wish, basically. Aside of that, I can have also preview on my HMI window and design something for the end user. Okay, so let's go for run up of my system. So first of all, my first task is just to connect the camera. So for sake of connection, I will use a general library which is called GenICam. GenICam is the general standard that is adhered by almost any vendors on the market. So if I use GenICam, I can make sure that my algorithms work with uh, any vendor of my choice, not only specific one I use. So this creates a quite nice situation which avoids a vendor lock in future. So once I drag and drop the block, I have properties here. So right now I have to select the proper device. So in my system, I have already connected the ACA 1300 by 200 UC camera, which is 1.3 megapixel color USB camera, which delivers 200 frames per second, basically. If I select it and then I drag and drop output frame to the preview port, and then I will play my program, which is in fact very simple. It is created by only one block. Then I can see that I have a direct preview of my camera. Now I'm moving my hand in the front of the camera just to show you that this is the live preview. Of course, the image is totally not perfect. So first off, I will just put my object in the front of the camera. And definitely with this settings of the camera, object needs more lighting. So right now I will turn off the light, and I will see that my label um, is quite blurry. So it means that I need to adjust my camera in order to see it perfectly. So right now I have to manually use the two adjustment rings on my lens, on my objective of the camera. Uh, so right now I'm adjusting the iris, which controls the general brightness of my image, and then I touch the focus ring, which slowly works out the perfect sharpness of the image. I can zoom in for better adjustment of the uh, of the sharpness. So it looks like this is the perfect condition of the imaging. Maybe a little bit more light, I would just add it. What I want to avoid is to go with the intensity beyond the dynamic level. So here you can see the the color probe shows the color probe shows 249 as a level of the brightness. So it is very close to the maximum of 255. So what I'll do, I will just reduce slightly my brightness in order to have better contrast. So right now it goes around to 210-ish, which makes perfect sense in this case. Okay, so once we are done with the setup of the camera, we can now focus on our algorithm. So I would, right now, what I would do is that I will devise a plan for doing three types of checks. First of all is the fixture. So I will just create a sub procedure for it. So I will call it fix on label. What it will do is it will follow the pattern so that we will know in the algorithm where the label is in the image, so that I can put any other tools relative to found pattern. So fix on label is my sub procedure. So if I double click it, I'm in my sub procedure, and I can add another filters here. Another one uh, is to read barcode. And the last step that I'll present today will be do OCR. So I created three simple functions. Then I will go into inside of each and do some stuff with it. So definitely each function needs some input arguments. So first argument for each function will be the image. So I will just pass image to every of these functions so that I have access to this image to do some analysis. There is one more step to do. I will add the loop clause. This is the specific operand, I would say, that creates a constant back and forth iteration over this algorithm. So I want this algorithm to iterate without stop. I don't want this algorithm to go to the end and exit the program. So this loop command makes sure that I will go back to the grab image operation. Okay, and now I can just focus on the fixed label first. So I will go inside. You can see the frame from the algorithm is available here. Right now I can just preview this frame. And what I want to do is to create some fixture point, some characteristic point on this pattern that will always repeat regardless the type of the bottle. Because as you can see, we have several types of the bottle. This is the type 1, this is the type 2, this is the type 3, this is the type 4, and what I'm looking for is just the repeating feature on these labels that is constant regardless the type of label I'm adding on the view of the camera. So if I put this label of one of the bottles here, I can just see that probably this the specific marking here is the repeating is the repeating um, is the repeating pattern for each of the bottle, so I can use it for the fixture. So how do I use it? I need to stop my program, and with a simple shortcut, Control and Space, add one of the pattern searching algorithms, which in this case will be gray model search, and it's called NCC2, locate objects NCC2. So what this particular function does is that I will now define the object of my search, and this block will search the instance of the single best fit model in the current image. So I have to, of course, connect the input to the input image, and then search region, of course, will be auto, which means I will search across the whole image. And then I will need to here to define my gray model. So as you can see, it is grayed out right now, which means empty. So I need to once iterate, and then I will enter into gray model definition. So my gray model should be maybe something like this. Okay, so this model will be right now defined, and every time algorithm is invoked, the model will be searched across the input image. So there is a number of parameters that I can tweak to make it work even better than default ones. For instance, I can search for minimum and maximum angle of tilt of the model. So let's say that minimum angle tilt will be minus 10 degrees and maximum will be 10 degrees. This means that my bottle can wiggle a bit, can change the angle a bit, and model will be still working. Without it, unfortunately, wiggling bottle will have a low hit ratio for my model. So I'm adjusting it just to make a better tolerance for angle changes of the bottle. And then I can also change a little bit of my scale of the model. So I will search for all instances of the scale from 0.9 to 1.1. Why do I do this? Because it may be the case that bottle passes the view of the camera in closer or farther distance, which will affect the scale of my model. So I want my model also to be independent of slight scale changes in practice. So with this in mind, I will just click next. Let's stay with other parameters as default. Maybe we will just use, yeah, it will define all the ins and outs of the algorithm by itself. So right now I'm just defining model as this one, and defining the output area like this. So I will just accept it. Okay, I have the warning about large model. Let it be the large model. The larger model is, the more parameter uh, variations I accept. So right now I accepted two parameters of variance, which is scale and tilt. So this is why this model is large. So let us play our algorithm and see how the output is. So the output of algorithm is the object match. And here you can see the result of the localization of my bottle. So as you can see, I can go left and right, and algorithm will determine right now and search across the image and align my align the search to the current position of the bottle. So you can see I'm wiggling it left and right a bit. Yeah, this is like 10 degrees. So if I wiggle it on the left too much, of course it loses the match. This is by design as of now. And if I go a little bit further and closer, still the match is working. So this is what I want right now. So let me stop the algorithm. And right now, I will need my alignment to be used, my alignment to be used in other tools. So my other tools will follow the search pattern so that I do not need to search for several features like OCR or barcode in the whole image. Okay, so this is uh, alignment of the output. So of course, my function of fix on label has to output the result of alignment. And you can see this result of alignment has the question mark at the end, which means basically that the output is conditional. So conditional means that it can be any result or it can be nothing. So I have to keep it in mind, because if there is no bottle, then definitely it will return so-called nil value, which is zero or null or void or nothing. So this question mark tells us that the result is conditional on, of course, depending on current view of the image and current execution of my algorithm. Okay, so I can see that fix on label just creates the output. I just drag and drop the output, and right now I'm going to the next step, which is barcode reading. So definitely I want to use the object alignment just to refine the area of search of my barcode to certain area. I don't want to search my barcode in the whole image, but I want to search my barcode only in area that is smaller and aligned to the bottle. So right now I have several choices. Let's just check the default ones, and we will just do barcode. And for the barcode reading, we have another block which is called read barcodes or read barcode. Let's do this one. Of course, it accepts the input frame, input image, and then I need to create the ROI alignment. So I want this barcode to follow to follow to follow alignment from the previous tool. And I want also to uh, let me just iterate once, okay? And I want to reduce my search area to only this one particular choice. So right now, ROI alignment is chosen. So I'm looking for the barcode in the coordinate system of my previous tool. And right now, in relation to this coordinate system, I am drawing a search area which will only be searched for. And then let's go OK. Let's split the screen to make barcode text output, and I can run the program again, and I can see that barcode position, and this is the barcode position that is found by this algorithm. So again, I'm moving the camera. Right now, my fixture is out of the view, So I cannot do uh, any barcode reading, but as soon as I have my fixture, then again, barcode area is correctly found. And right now, I can also add the align region of interest. So you can see that my selected region of interest is also aligned and also is going after my alignment from the master object, okay? So here we are with the barcode. We have the readout. Let's check for other bottles. This one is working. Of course, if I tilt it too much, then the initial match of the fixture object is not matching. Is not matching anymore because it is significantly different from what I've defined. So I need to make the bottle perfect, maybe not perfectly, but within tolerance, the front up front to the view of the camera. So second bottle, third bottle, again, and we can see on the bottom that the barcode has the readout. So right now, what I can do, this is my output of the barcode reading to the algorithm. You can see that this barcode text has also question mark because it also may or may not detect something depending on conditions, depending on maybe there is a broken label, maybe there is a missing label, you never know. So we will take care about this question mark in the later time. And the last thing to do is the OCR stuff. So again, I'm accepting the frame, and algorithm I'm gonna use today will be called DL read characters. So this is very robust algorithm based on deep learning model, which accepts the image and is searching for all the texts within the range of the defined size of the character. But before that, I have to again to pass my object alignment just the same way as I did with the barcode. I have to pass my object alignment to the OCR, make the input, and I will also have to define my region of interest. In other words, what I want to read for OCR in my image. And the area of the reading will be, of course, the best before date. So I will try to decode these two lines of, of inkjet printed date. So in the first line, we see the date of the production, no, of the validity best before. This is 2027. So, and on the second line, we see probably this is the time of the production and some cryptic characters that probably tell something more about the production itself. It may be the production, the batch number, or whatever. We don't know at the moment. So in order to make my deep learning character reading work, I need to again to define my alignment. So I will align to my previous object again, and I will in this case I will also define the region of interest. Again, this is empty. I cannot find anything, but I need to run my algorithm once. And yeah, I forgot to put the bottle on it. uh, I forgot to put the bottle on it. Okay, we have the bottle on it. Stop. And right now we should be able to have the background of the image to define are the where are the characters to be found. So definitely this is the area where I have to find my characters. So let's limit to this area so that OCR doesn't do a recognition in the whole picture, because this operation can basically kill the execution time if algorithm has too much to search. So I will limit only to my area of printing. If done so, I can just run again, and let's see what will be the output of my algorithm. So I press play, and right now characters, I can put it here. I see that something is basically detected. It's not perfect, and in the bottom preview I will show what is detected. So I have basically the array of detected characters. So as I can see, nothing is perfect here. So I need to look at the specific parameters of this algorithm. First of all, in order to make it work, I need to measure the height of the expected text. So I take the ruler tool, and I'm right now trying to determine the average height of the sign. So this is 25 pixels. Here is 24. Here is 25. 25. It looks like 25 is pretty good hit. So I can see that current character height is a little bit too much, is 35. So I limit it to 25. And maybe just for the starter, in just to make these things work, I will also change a little bit the expected character range. So character range is the range of the signs I'm actually looking for. Uh, let me just zoom a little bit for the moment. So default one is the uppercase alphabet, lowercase alphabet, numeric digits, and several special marks. So okay, definitely I can skip the lowercase. I will leave the uppercase and digits, and additionally I need to recognize the dot and the colon. So definitely it's missing here. I don't need the minus. I don't need slash. So I will add dot and colon. So this is the actual range of the characters I'm about to seek. And let's try again and see the results. Empty mask in character range. Okay, it's always empty mask in the character range. Okay, let's fix it. So dot and colon. Maybe there was, let's try again. Okay. There will be dot and the colon. Maybe start with dot first. Let's see if this is valid. Okay, this is valid indeed. But we have not sufficient recognition here. So right now, what I will do is I will adjust a little bit the angle of the camera so that camera is working right correctly. Okay, and let's find out what's happening more in order to make a correct reading. Okay, still I have non-sufficient readout. So let us dive into more parameters. So definitely what I want to do is just to change the pre-trained model type to the extended. So extended model will make sure that the search is gonna be a little more exhaustive than the standard. Let's change to and see the results. And the results are still not perfect. Let's inspect the region of interest, and we see what's happening. Region of interest is not properly aligned. And here we have the error that I've done. I need the coordinate system to point out to ROI alignment input, and because it was just a fixed. So right now, it should be okay. Let's try again. And here we are. We have a perfect readout of the model, of the text, except this one. So we need to fix and try to add a colon. And as we added the colon, we have a complete readout of the text. So this is 07.10.2024, and the next line is read out correctly. We can see, I will just zoom in. So this is 07.0628 semicolon, and looks like readout is just about perfect. Okay. So we have a text and we have a one-dimensional array of the text. So what do we do with it? So definitely this form of the output is not perfect for us. We would like to have like, for instance, separate lines and the characters joined together into single strings. So for this sake, I will make another call to function, which is helper function in this case. So this function is called merge characters into lines. So this is a pure function that computes the correct positions of the characters from the previous tool and merges it, just as name says, it merges it into single lines. So on the output, I should have an array of strings, which I'm dropping right now here. I should have array of strings that contain a particular line. So this would be the string 0, and this would be the string 1. Let's roll this algorithm and see what's happening. So definitely I have merged some characters, but instead of 2 lines, I get some segmented chunks of neighboring characters. So definitely, again, I need to look into parameters of the function. So I can see that maximum gap between chars is a little bit too small. It's the quarter of the a character height. So definitely I will need to go up with this value, and as I go, you can see that at some point the result is correct. So I have 2 lines. Line number 0 denotes the date, and line number 2 denotes the the second line, which contains time and some markings. Okay, so we are done with it, and I will stop it, and again I will put the result outside my function so that we are able to uh, have access to our results in the top level of my algorithm. Okay, so right now we have a fully working algorithm which basically does 3 steps: fixes correct position on the label, follows all the tools which are barcode and the which are barcode and the OCR on the best before date. So we are done with point 3 of our agenda, which is big 3 algorithms which are done right now. So let us focus on the HMI. For sake of this HMI, I will change my working preview to another one. As you can see, I can have as much as three different previews of the same algorithm. So currently we were using the preview one for current uh, layout of the previewed values from the algorithm. But as we switch to second, we have right now clean, empty preview, which we can organize in our favor. So for sake of this favor, I will just make a little more room for the preview and put the HMI window to the view. So what we want to right now to do is to have a simple preview of values and simple HMI functionality. So first off, I would add something that starts and stops my algorithm. Okay, so as I'm previewing the HMI, I have an additional toolbox here, which is HMI control. So it contains all the controls, all the possible buttons and blows and whistles, which I can put on the form. So first of all, I'm looking for on-off button, which will just do on and off with my algorithm. Okay, so how to do this? How do I uh, turn my algorithm on and off? So I need to select my whole algorithm and create so-called variant step. Variant step is the counterpart of if-else statement. So if I enclose it, on off operation. Okay, so if I enclose all my existing algorithm into this variant filter, then it creates two execution workflows, which means execution on false and execution on true. And this operation of enclosing put my old algorithms, as you can see, to the true statement, which is okay. So right now, what I need to do is just to output the value of this button to the condition of my filter, so that this button can control the way of execution of this filter. So if the button is off, false, then nothing happens. And if the button is true, then I will just go with my algorithm. So in order to do that, I need to drag and drop output value, which is Boolean value, true or false, to the condition of my filter. Okay, and here you can see the condition of execution comes from HMI, from this button. And what I want to do next is I need to add some simple preview of my of my images. So I will add a component which is called zooming video box. So I will drag and drop, make it bigger, maybe add some features like back color. Let's make it gray, a little bit gray. Okay, here we are. And right now, of course, it will accept the zooming image box will accept the image from my algorithm. So I need to go to my true part of the execution. And in Genicam grab image, I need to drag and drop output frame to the image. So we can see if it works, play, and on we should see the image. And we see the image. Of course, this is the pure image from the camera, so it doesn't show us the tools we've been able to see in our preview one, but we can just output a different it in a different way. First of all, I want to see the barcode in the read barcode. So for sake of this operation, I will add the text. I'm sorry, this will be not the toolbox, but HMI, and here is the text box, and text box will be called with the label and the label will be read out. So it will be barcode readout. Okay, and the barcode readout will accept the barcode text. So I again drag and drop barcode text on here, and now it should connect and show the current readout of my barcode. And for sake of, let's say, of making some decision, I will just copy and paste this control and make barcode expected field. And barcode expected will be one of the barcode readouts. I have here the barcodes of the bottles. Let it be this barcode with 250. So I will just put it here and make and put it in the text box, which is text I put it in the text box. So right now, if I connect the okay, so this is connected. This has not to be connected for the time being. If I read if I run the program, then you can see that on the top there will be uh, a readout of the current toolbox. There's one small issue with it. Once we have no readout, the previous last read text stays. We have to cover it. So for this sake, we will add some called merge default and the string. What does merge default says? It says if there is no readout, so if the conditional is not readout, so if it's 0 or null, then please put it as a default text. Let's say default object will be no readout, and this no readout should be then put into the input of the text. So this will make sure for us that that algorithm, if there is no readout from algorithm, then the value passed to the control is correct, so no readout. So if I put object, so we have a readout. If we have no object, there is no readout. And one more step, of course, we have to make sure about the correctness of our code. So let us add another control, which is pass fail indicator. In this pass fail indicator will turn green once the readout is correct and turn red once the readout is not correct. But in order to have this Boolean value, this result of readout, we have to make some condition, uh, and for sake of this condition, we will put some code. Um, this is the I just forgot this name, but let me formula. Yeah, we have to put the formula of the. We have to put the formula that will compute the correctness. Okay, so let's name the output of the formula barcode correct, albo barcode okay, and yes, we have an error, but we also need some inputs for it. So first of all, our input will be the default value of the readout. So in will be readout barcode, and the second value will be expected barcode, which is string, of course. Okay, and expected barcode is in this field. So I will just go without text and put it to the input and readout. And now I have to create the condition. So my barcode okay is every time where readout barcode is equal to expected barcode. And right now I have, you can see I have Boolean value. So this Boolean value right now is equal true when the expected barcode is equal to readout barcode and false otherwise. So what I want to do is just to drag and drop this value to the to my indicator. Okay, so let's run it finally. Let's start my algorithm, and we can see that it is failed. So I'm right now going through the bottles. So there is a readout, but the result is fail, which is correct because numbers are not matching. Another bottle, again failed. Yes, failed. This is 8. Another bottle, failed. Another one, failed. And the last one should be green. And there we are. We have detected and we have created the green pass value. So right now, this value can be, of course, put into outside world. What are the options? First of all, we can output it via TCP/IP connection. Sorry, in the toolbox. We have a long list of tools that will output and connect to the external systems via simple TCP/IP connection. We can also do different kinds of communications for particular devices. For instance, if I go to third-party device, I can use, for instance, Advantech Adam modules that are I/O modules via Ethernet. So basically, This is one of the most popular ways of outputting values in the electric way. So high level and low level, depending on the result of my inspection. Or I can use, for instance, Hillshare cards, and with Hillshare cards, I can have a possibility to connect to the wide variety of the available interfaces, just like OPC UA, like mm, like there are there are many more which I cannot find right now name correct for, but for instance, yeah, I just forgot it, but I can just check and write in the comments. So basically, I can output my results of checking to outside world, so that something can be happened basically. Okay, so here we have our complete exemplary application with the simple interfaces. So thank you very much for this presentation. I will pass it over to uh, to Philip to somehow summarize our meeting today. Thank you very much.